So looking at this from the glucose molecule, C6H12O6. Look at that top picture up there. Do you see C6H12O6? You do. Because when you look at a carbon ring, everywhere that there is a bend, that means there's a carbon. And then H's that are present and the O's that are present. So the glucose molecule, C6H12O6, which carbon to hydrogen bonds plus the oxygen there is loaded with energy. Okay? So that one little glucose can provide roughly the 36 ATPs. Do you guys remember that? Now, the process of glycolysis, okay, this process occurs in the cytoplasm of the cell. Glycolysis occurs in the cytoplasm of the cell. Glyco, letting me know that it's a sugar, and then lysis, lyse. What do you do when you lyse something? Do what, Regina? We split it, we cut it, we break it apart. What if I just told you is now going to happen to this glucose molecule? If it's glycolysis, and if glyco is telling me sugar, lyse means to split, what am I going to do? We are going to split that glucose. That's what glycolysis is. That's it. We take a sugar that is a 6-carbon chain, C6. Is everybody with me? And I'm going to split it. Guess what that carbon chain is now going to be? Rather than C6, it's going to become split 6 in half. 3. It's going to become a 3-carbon chain. That's what I did. That's it. I split that glucose in half. The initial process to do this needs energy. The cell actually has to expend 2 ATPs to split that glucose molecule. So it takes energy to get energy. Ever heard that before? It's sort of like, okay, now I got to start eating right, and I know I got to start going to the gym, but I really just don't feel like it. But, okay, let's try it for 3 days. Okay, day 1. Day 2. Day 3. Okay, well, maybe not too bad. 3-4 weeks into it, you're feeling so good from trying to eat right and go to the gym, can't nobody keep you from going to your gym for the day, okay? Other things might try, but it's like, no. So we actually have to expend some energy to get energy. Now, in that glycolysis that's going to occur, we split that glucose molecule, and we now turn it into a 3-carbon chain. When we split, okay, we now take 3 and 3. I don't care about y'all knowing all this stuff right here, okay? At this point, we're talking about it in terms of the glucose molecule. Glucose molecule goes through the process that's going to occur in the cytoplasm, and it can go through what takes place in the mitochondria. The glucose molecule is the only one that can go through glycolysis. And glycolysis is simply splitting the glucose molecule. That's what I'm wanting you to know at this point, okay? Now here's what happens. When we take that glucose molecule and we split it, and we get the 3-carbon chain, and now we've got all of these little groups that were hanging off of that C6H12O6, and a lot of stuff got exposed, and we kind of provided some energy, so we gave it some phosphates, and when we changed the form of it, let me think here for a second. I messed with my electrons. Now, what is it that we find in the mitochondria that produces and gives us the majority of those ATPs? My electron transport chain. Ding, 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 ding. Yes. My electron transport chain. I just told you that I had to rearrange that carbon. I messed with the electrons. What happens to those electrons? How do they go to the electron transport chain?
Carrier molecules.
I got some carrier molecules like NAD, FAD. But then, once I deal with those electrons, they become NADH, FADH. Why?
You got them used, they got the electrons. Is it like they give electrons and then like they also need like a proton? They got electrons.
The only way to balance something when you mess with the electrons is for the H plus to be present. So those electrons, they get now still in the cytoplasm of the cell. So I messed with the electrons. Electrons got exposed. They got picked up by my electron carriers. The only way for me to balance that is to have some of the H pluses. So now where I had an electron carrier, the NAD, and it got those electrons, the only way to balance it was with the H's. And now I've got like this little car, okay? Think about this little car that'll hold those electrons, pulling H's behind it. And that's still in the cytoplasm of the cell, but it has to get to the mitochondria's inner membrane, where we find the electron transport chain. So that little car that's carrying those electrons with the H's coming behind it, okay, is now going to travel to the electron transport chain. And guess what? Lets those electrons off. And because the hydrogens have to go with the electrons, guess what? Hydrogens will drop off too. So, at this point, I've gotten some electrons, I've gotten some hydrogens, I've split my carbons, okay? I have lysed my glucose molecule. I'm going to have some ATP given off. I'm going to have some electrons given off. And when I'm done, I end up from those that 6-carbon chain that I split in half. Because I split it in half, I now have 2. Okay? I'm going to now end up with 2, what we term pyruvic acids. So at the end of being in the cytoplasm, where that glucose molecule came in, we split it, we got some electrons off of it, we had to give some energy, but I also produced 2 ATPs, actually 4, because we split the molecule in half. But because I had to expend 2 ATPs, my net gain at this point is only 2 ATPs. Can energy production stop right there? Can your body survive on energy production right there? Yes. For a short amount of time, because this would be anaerobic fermentation. Have I even mentioned oxygen? For something to be aerobic, you got to have oxygen, right? At this point, the process to create the 2-pyruvic acid is anaerobic. And your body does this. Okay, it's time for us to go exercise. All right? That means for today, we're going to do a 5-mile jog. Now let me tell you, right off the bat, see me running, you better run with me. Okay? Because I don't run. All right? But I use it as the example because when you begin to, after you do all your warm up and stretch and everything, okay, then you start to take off on your run, okay? You start to take off and you're up and you run, and then, getting to the point where, okay, I haven't gotten into the stride yet. Okay, wait a minute. All right, 6-minute mark. Okay, I'm at my stride, and up to that point where you got into your stride, your body was giving you the energy anaerobically. It's the reason that when you're done with that part of the exercise, you're sore. Because that process gives off a huge molecule called lactic acid that builds up in your muscles, and you get sore. And then your body begins to go into recovery, which means it'll take those pyruvic acids and go into the mitochondria for aerobic respiration. But for every glucose that it burns up, it's only giving you 2 ATPs. Not efficient at all, but can be done. Take a break, back at 12:30.